All right, Algebra 2, we are in Chapter 6, Section 5. Let's review our warm-up exercises. Identify the type and sample described, then tell if the sample is biased and explain your reasoning. First of all, a school newspaper posts an online survey on their website about the food served in the cafeteria. They present the results of the students who respond. So school newspaper, online, their own website about the food served in the cafeteria. I'd say we self-selected, and it's quite biased. Okay, it's their own website, and they posted it. So those results show only the feelings of students who volunteer for the survey. That should be a V. All right. A grocery store wants customers to rate their customer service. The store manager surveys every 20th century customer leaving the store during the day. 20th century customer, I think that's an age. Systematic is one of our options if you review last chapter. It's every single one, so I would call that unbiased. I'd say that's pretty representative. Representative of the shoppers. All right, let's get into what we're doing today. Surveys. Previously, you learned that in choosing a sample of a population to survey, you should do your best to select an unbiased sample to help ensure that the survey data represent the population. Random samples are preferred since they are less likely to be biased. We don't like bias, right? In designing the survey, it is also very important to word survey questions carefully. Answers to poorly worded questions may not accurately reflect the opinions or actions of those being surveyed. Questions that are flawed in ways that leads to inaccurate results are called biased questions. Questions may be biased in several ways. The wording of the questions may encourage or pressure the respondent to answer in a particular way. The question may be perceived as too sensitive to answer truthfully. The question may not provide the respondent with enough information to give an accurate opinion. Bias may also be introduced in survey questions in other ways, such as by the order in which questions are asked, or by respondents giving answers they believe will please the questioner. So tell why the question may be biased or otherwise introduce bias into the survey. Describe a way to correct the flaw. If you look at A reporter asks parents, do you agree with the school board's proposal for new technology in our school? Question B, which we'll get to next, a dentist asks patients, do you brush your teeth at least twice per day and floss every day? If you look at A, I'd say the question assumes that the respondent is familiar with the proposal. Hold on. It made better sense for me to write it out first. For A, this assumes that the respondent is familiar with the proposal. Okay, we don't know what the proposal is. It says, do you agree with the school board's proposal for new technology? They could be in favor of new technology, or they'd like, no, get all technology out of the school. To get accurate results for that lead to valid conclusions, you need to state the proposal clearly using neutral language before asking the question. Okay, now let's look at B. B says, a dentist asks patients, do you brush your teeth at least twice per day and floss every day? I need a new page. Okay, give me a second to write it out. That was a lot of writing. I would say patients who brush less than twice per day or do not floss daily may be afraid to admit this since the dentist is asking the question. One improvement would be to have patients answer questions about dental hygiene on paper and put the paper anonymously into a box. Experiments and observational studies. You've seen that surveys are one way to collect data, but different situations and purposes require different data gathering techniques. For example, many studies are designed to try to determine whether a quantity that varies can be associated with measured differences in two different groups of individuals. First of all, an experiment imposes a treatment on individuals in order to collect data on their response to the treatment. The treatment may be a medical treatment, or it can be an action that might affect a variable in the experiment, such as adding methanol to gasoline and then measuring its effect on fuel efficiency. In some cases, it might be difficult to control or isolate the variable being studied, or it may be unethical to subject people to a certain treatment or withhold it from them. In this case, an observational study is used. An observational study observes individuals and measures variables without controlling the individuals or their environment. So let's determine whether each situation is an example of an experiment or an observational study, and then explain. So first of all, a researcher asks college students how many hours of sleep they get on average per night and examines whether the number of hours of sleep affects the student's grades. Let's pause there for a second. I'd say this is an observational study. If you can just write that down as I talk, that would be an observational study. To explain, you're just gathering data. You're not affecting anything. You're not controlling anything or changing anything. A Parks Department employee wants to know if latex paint is more durable than non-latex paint. She has 50 park benches painted with latex and 50 park benches painted with non-latex. That sounds like an experiment. Okay, we've tested this and that, and we're gathering information. So definitely an experiment, and that's my explanation. Oops. Moving on. Tell whether the survey question below may be biased or otherwise introduce bias into the survey. Explain. Do you, like most people your age, enjoy watching the latest music video? Well, I can tell you right now, I don't like this part of the statement. So I'm going to say it's probably biased because I'd be pressured by that most people your age to answer a certain way. You know, if I said no, I might feel that I'm not like most people my age. And that's not very nice. Determine whether the situation described in the research summary shown at the right is an example of an experiment or an observational study, and then explain. The Faster website. To test the redesign of its website, an online bookseller assembled 96 users of the site and randomly divided them into two groups. One group used the new website to make an online purchase, and one group used the old website to make the same transaction. Users of the new site were able to complete the purchase 22% faster. Sounds like we are experimenting. Okay, we've got a treatment, which is a new site versus an old site, is imposed on individuals, and data is gathered on the treatment. Pretty cool. Moving on, controlled experiments. In a controlled experiment, two groups are studied under identical conditions with the exception of one variable. The group under ordinary conditions is called the control group. The group that is subjected to its treatment is the treatment group. In a randomized comparative experiment, individuals are randomly assigned to the control group or the treatment group. The comparison of the control group and the treatment group makes it possible to determine any effects of the treatment. Randomization minimizes bias and produces groups of individuals that are theoretically similar in all ways before the treatment is applied. Conclusions drawn from an experiment that is not randomized comparative experiment may not be valid. Let's try an example. Determine whether the study described in the health bulletin below is a randomized comparative experiment. If it is, describe the treatment group, and the control group. If it's not, explain why not, and discuss whether the conclusions drawn from the study are valid. Oh, that was a lot of words. Okay, if it is, describe the treatment group, and the control group. If it is not, explain why not, and discuss whether the conclusions drawn from the studies are valid. Milk fights cavities. At Ashland Middle School, students were given the choice of drinking milk or other beverages at lunch. That's just silly. 50 students who chose milk were monitored for 1 year, as were 50 students who chose other beverages. At the end of the year, students in the milk group had 15% fewer cavities than students in the other group. Let's see. I've got 50 students chose milk, so that is not random. Because they self-selected. Okay, let me get a new page. So what we're going to say here, it is not a randomized study. Not a randomized comparative experiment. In fact, it is an observational study. Because no treatment is imposed. I'd say the study's conclusion that milk fights cavities may or may not be valid. Those kids self-selected into 2 categories. There could be other reasons why the students who chose milk had fewer calories. You could assume that kids that choose milk, they live in a home where they drink milk for dinner every day and they brush their teeth every day, and they've got, parents that are super duper strict. And then maybe ones that don't drink milk are drinking soda every day, which we know isn't very good for our teeth. So they could have other eating habits that would impair their dental health, right? So that's my conclusion. Determine whether the study described in the research summary for guided practice exercise 2 is randomized comparative experiment. If it is, describe the treatment group, the control group. If it's not, explain why not. I'm going to go back and read the guided practice example 2. That is the FASTER website. Okay, so you can go back and read that, the FASTER website. And we are going to say that is a randomized, a randomized comparative study. So the treatment is the new website. The treatment group. Are individuals using the new website. Yikes. What else do we need? The control group are the individuals using the old site. I think last example, well-designed studies. Randomization is a key element of a well-designed study. How randomization applies to different kinds of studies varies, as shown below. We've got sample surveys, observational studies, and experiments. Surveys do not compare groups and do so not address cause and effect. Good observational studies and experiments are designed to be comparative, to compare data from two or more groups looking for a relationship between variables. But only a well-designed experiment can determine a cause and effect relationship. So go ahead and read through this, knowing causality is important. Comparative studies and causality. An observational study can identify correlation between variables, but not causality. Variables other than what is being measured may be affecting the results. For example, vigorous exercise in older people correlates with longer life. But comparing groups only exercise and lifespan ignores other factors, such as that people who are unhealthy to begin with may not be able to exercise vigorously. A rigorous randomized comparative experiment by eliminating sources of variation other than controlled variable can make, I can't read it, hold on. Can make valid cause and effect conclusions possible. Very cool. Let's practice. Explain whether the following research topic is best investigated through an experiment or an observational study. Then explain how you would design the experiment or observational study. You want to know if listening to music using earphones for more than 1 hour per day affects a person's hearing. Oh. So, the treatment, which is listening to music using earphones for more than 1 hour a day may affect an individual's hearing. That's not cool. So it is not ethical to assign people to a control or treatment group. Not cool, right? You're going to lose your hearing, and you're not. Winner, winner, loser, loser. So I would use an observational study. How could we do that? Let's see. You could random. Goodness. Choose one group of people who already listen to music with earphones for more than an hour. Okay, you're just going to randomly choose people that do that, and then randomly choose ones that don't. And you can survey that. How many hours of day do you listen to music with headphones? How many hours a day do you not, just survey people. So randomly choose one group of people who don't listen to music for more than an hour a day. And then just collect data. Okay, monitor the people. Monitor their hearing. Give them hearing tests periodically. Oh gosh, we finished. Daily homework quiz. Okay. I have 3 slides of them. Here's 1. There's 2. And there's 3. Nice work. We'll see you tomorrow.